Hello astronomy, this is a supplemental video. Since we don't have so much class time, I thought I'd throw in maybe some things I might gloss over too quickly or maybe not hit at all, but I want you to know. So think about this. We've been talking about how the sun moves across the sky. You know, I drew the big bluish black thing sky and the flat earth, it's not really, and then showed how the sun appears to go around. And I said the stars do the same kind of thing. You know, it was like here was the sky and the flat earth, and we had like a big axis of rotation. And from Atlanta at 34 degrees north of the equator, it's tilted so the North Star is 34 degrees above the horizon. There's the North Star right there. And everything appears to go around like that. The sun, the moon, the planets, the stars, all of them go that way. They all appear to come up kind of in the east and go down kind of in the west, as if the whole big thing is just rolling around. Okay, so we talked about the sun and how it kind of migrates north and south of the actually thing called the celestial equator, halfway between the celestial poles. Imagine that. And I showed the stars. I did say that you know, a star close to the north celestial pole is going to be a circumpolar star because you won't see it set. It's seen from here in Atlanta. On the other hand, there's stars way down yonder down south that you never get to see here, but those people in Buenos Aires or Sydney get to see them because their axis is tilted differently, you know. Well, I want to concentrate on the next brightest thing in the sky, the moon. I want to talk about what the moon appears to do. Now, basically, it does that. The moon moves across the sky a lot like the sun does. It rises in the east and sets in the west, generally, sorta, kinda. I mean, sometimes it rises in the southeast or in the northeast and sets in the southwest or the south or the northwest. It generally stays up for about 12 hours, not exactly always, actually a little bit longer than that usually, and down for about that much time. The moon can be out at various times of night, but it might not be out, and it can be out in the daytime. Maybe you've seen it in the daytime. We're gonna try to explain all that stuff, get the moon phases all down here in just a minute. So, why does the moon look like it looks? What are some ways the moon can look? You know, it can look like that. It can be full, right? You know, sometimes it's a little crescent, right? Sometimes it's a half moon, you know. Sometimes it's this thing where it looks like you've done a bad job of drawing a circle. Now, I can draw a pretty good circle sometimes, but you might think when I draw this that, oh, Mr. Ahrensberger just blew it. That's the worst circle he's ever drawn. It's not supposed to be a circle. This is a moon that's not quite full. See, it's a moon that's got a little bit of dark over here. Oh, kind of like about the same amount of dark as this is like, because, you know, this has got a lot of dark over here. So these are possible moon phases. Here's something that's not a moon phase. This right here is not a normal moon phase. I've seen it like that during the lunar eclipse, but it doesn't normally look like that. So why would the moon look like anything? Well, there's a common explanation that people tend to give, even like Harvard graduates probably think this kind of thing. If I ask, what makes the dark part of the moon dark? A lot of people think it's, what if you're thinking this? That it's the Earth's shadow. No, it can be during a lunar eclipse, but that's rare. Generally speaking, the dark part of the moon is in the moon's shadow, not the Earth's shadow. You see, it's simpler than you might have made it. It's just that the moon is a ball and it's lit by a light, the sun. Now, tell you what I'm gonna do. Let's see, I've got a light over here. I'll show you what I mean. Here we go. See, there's a light, it's the sun. I'm gonna make the sun seem to be brighter by making it darker in here. Look at that, there we go. Now, I'm going to attempt to let you see, I hope I do this right, what the moon would look like if I am the Earth. Now, if that's the sun over there, and I'm the Earth, maybe you can tell from context that it is high noon on my nose. And there's the shadow of the phone, eclipse. Okay, it's high noon on my nose. Now, as I rotate around, see the sun's over there. If I rotate around here, now you see half my face lit and half my face dark. Now, what time is it on Nose Mountain? Don't go exploring the caves of wonder. But anyway, on Nose Mountain, it's about 6 p.m. or so. You see the sun is shining on the western flanks of Nose Mountain, and here it's getting into the evening shadows. And if I continue to rotate around, and I'll show you me, oh, here I am. It's midnight on Nose Mountain. Whoa, lunar eclipse. If you're the moon, Anyway, see, it's midnight on Nose Mountain. Now, there's enough light in the room so I'm not all the way dark, but you get the idea. At least I'm not that bright. Okay, so it's midnight, and then the night goes on, and the sun comes around, and I've turned around, and now da 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 da. I don't know if you know who Edvard Grieg is, Norwegian composer. Pretty song. Da 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 da. It's 6 a.m. and now it's back to noon, but I haven't shown the moon yet. Let's see if I can do this right. This is going to be my moon here, and what I think I'll do, I will face the camera out the way I'm looking. So that means I'm turning around and just hoping you really see what I'm pointing at. Okay, so there, it's noon, I guess, and there's the sun. Now, if the moon happens to be here, you ain't gonna see it. That's all the dark part of the moon. Not only that, the sun's in the way. It's daytime. It's broad daylight, the sky's all blue, and the birds are singing, etc. So you're not gonna see that moon. Now, as we go on through the evening here, that moon, the afternoon, that moon's just gonna set and you're not gonna see the moon all night. And you go, what happened to the moon? I never saw the moon all night long. I stayed up all night and never saw the moon. That's because this was a new moon. A new moon is between the earth and the sun, and you don't see it unless there is a total solar eclipse, which is rare and amazing. But anyway, so the moon doesn't just stay there. It gradually moves around the earth. So it takes it almost a month. It takes it in the context and the relative frame I'm talking about, it takes it 29 and a half days to do this cycle. So it's going to be here one night, here the next night, here the next night. Let's go through about like 3 nights. There we go. All right. It's not really night, though. It's daytime. Look what you see. There's the sun over there, and not very far away in the sky is the moon with just a sliver showing. That is a crescent moon. It is called a waxing crescent moon because it's getting more full every night, and this is how it happens to look tonight. Now, it's noon right now, and the moon is out. You see the moon quite well in the afternoon, but by about 6 p.m., and I can't even see the field of view you're seeing, but about 6 p.m., you'll lose that thing. It sets. Actually, a little after 6 p.m. The sun sets about 6. Maybe it sets about 8 or 9. And it's gone for the rest of the night. You don't see it the rest of the night. But it keeps moving its way on around. And I'm going to switch arms here. It's getting tiring. Okay, so now this is noon. This is 6 p.m. with the sun over in the west. See, it's about 6 p.m. And here's a moon that looks half lit. You see the right half is lit, the left half is dark because that's where the sun's not shining. And you would have seen this moon as early as about noon. You see it just fine and dandy at 6 p.m. with the sunward side lit because the sun is lighting it. And you're going to see it as the night goes on. You'll continue to see it until about midnight. It sets about midnight. But it's high and mighty at 6 p.m. This is about a week after it was new. It continues to go around as the days go by, and the days go by. Look, there I am. But then it kind of gets to maybe be over here about, say, well, you'll see that. There we go. This is about 10 days after new moon. And you don't see this at noon. It comes up about 4 in the afternoon. And in the evening, around, say, 9, 10 o'clock in the evening, you see this moon. It is most of the way lit. It is a gibbous moon, a waxing gibbous moon. It's most of the way lit. Just the right half is kind of dark over there. Then, of course, the days go by, and the moon comes around further and further. Here is, of course, a full moon. You don't see a full moon at noon because it's off in the opposite direction. The first glimpse you get, and the field of view of this thing is probably not wide enough to show this, but you'd be seeing it out of the corner of your eye about now, rising in the east. And by midnight, high and mighty, high and proud in the sky is a full moon. It's all the way lit up. And I guess you're seeing the same thing I am. Okay, it can get into the Earth's shadow and cause a lunar eclipse, but it doesn't usually. Usually it misses the shadow above or below because the scale's kind of off here, and really it's quite a bit further away. But that moon, the full moon, rises about 6 p.m. It's up all night and sets about sunrise, like the opposite of the sun. But of course it comes on around, and there becomes this moon that I see in the early morning hours. I'm looking off at about 3 a.m. now, and I'm seeing this waning gibbous moon with the left side mostly lit. And the night goes on, the sun comes up, and that thing sets. Here is a third quarter moon. Now, you know that half moon I showed first? It was called a first quarter because it was a first quarter of the way around. This is 3/4 of the way around. And this moon rises about midnight. This is the third quarter moon, rises about midnight, high and proud about 6 a.m., looking like that. And then as the morning goes on, it sets as the sun comes up. And of course, the days go by, and then you get this waning crescent moon. Waning crescent moon comes up in the early hours of the morning. It's easy to see at dawn. It's actually still up in the daytime if you can see it in the blue sky, you know. And then it comes around, and then it gets to be new again. And I hope you could see all that. I hope. Put this back down. So the moon has this phase pattern. It's discussed in the book. It's discussed, there we go. It's discussed in my little ecliptic notes handout thing or PDF that I showed you. You can see it in there. And so I want you to know those moon phases. We'll talk a little bit more about it in class, but I wanted you to get the basics of it. Now, the thing is, the sun and the moon both do the following. Now, there's another map in the talking about in the book, and also it's in my ecliptic notes PDF because it's called the ecliptic. What I want to do is show you a map of the whole sky. Now, you know, maps of the whole world, the best one's a globe. Globes are the best kind of map of the whole world because the world's round. You know that. But they make these flat maps of the earth, and they're kind of split like Alaska and Russia, where they almost touch, you know, or split way across opposite sides, you know, and you flatten it all out. It always distorts Greenland and so forth. Well, this is going to be a map of the sky. So here's my map of the sky. There we go. This is north, this is south. You're going to be surprised about what I'm going to say now. You're going to think I'm wrong, but I'm not wrong. This is west, and this is east. Now, why did I make them backwards? It's because this map is where you're looking from the earth out at the sky, from the inside. You know, sometimes you're inside a store and you look over and there's a sign in the window that says Nepo. You go, Nepo, what's that? You go, dang it, open. Better than being in there and it's desulk, closed. So anyway, when you look from the inside out at something, it looks backwards. So anyway, this is correct. West is really over there. If north is there, you could try it. And this is maybe the North Star's up here. There's stars all over this map. It's a map of the stars. Here's like Orion is right here, and Sirius, and you're going to learn some stars later in this class anyway. And down here is Sagittarius, and there's Leo is right here. There's Leo, and Pisces is kind of over there. And there's some stars. In any case, here's a thing called the summer triangle. So there's a map of the stars. And what do I put on there? Well, stars, of course, like continents, go on a map of the earth. But, you know, you don't mark as a permanent mark where a certain tour bus is on the earth because it's moving around. The sun is like that. The sun's like a tour bus. And the trip it takes, we already know from what we've said before about the sun, you know, being sometimes further north, sometimes further south in the sky. We already know that the sun is wandering north-south. Well, at the same time, it's headed east. Now, wait, that's confusing because, you know, the sun goes westward across the sky. Yeah, but compared to the stars, it's going eastward. Like if you're on a bus going to Birmingham, Alabama, that's west of here, out I-20, west of here, that way. So if you're going 70 miles an hour on a bus, you're going towards Birmingham, you're going west. But what if nature calls and you need to go use the bathroom in the back of the bus? You were up talking to the bus driver, and you walk back towards the back of the bus. Which way are you going? Well, it depends. Compared to the people on the bus, when you're headed toward the back of the bus, the opposite way the bus is going, compared to them, you're headed east slowly, like 2 miles an hour. Compared to the hitchhiker out on the side of the road, you're still going west with the bus almost as fast as it is. Say it's going 70 miles an hour and you're going 2 miles an hour back towards the bathroom. Well, then that means you're going 68 miles an hour east compared to them. So please understand, this entire map whips around the world every 23 hours and 56 minutes, or the earth turns the other way. Maybe that's it. But in any case, what I'm saying is compared to that background, the sun is creeping backwards, kind of like going to the bathroom on the back of the bus. And this is its path, called the ecliptic. The ecliptic. It wanders as much as 23.5, you've seen that number before, 23.5 degrees north of the celestial equator and 23.5 degrees south of the celestial equator. By the way, the celestial equator is the set of all points that would be seen as overhead from the Earth's equator. Splits the sky into northern and southern halves, you could say. So the sun does this trip, and how long does it take? Well, it rises and sets every 24 hours, but it's creeping along through against the background of the stars. This takes a year. This takes 1 year for the sun to do this trip. So it's like here in March, in fact, March 21st, the sun's, there it is on March 21st. March 21st, the sun's here. By like April, it's here. June, it's up here in June. It's here in September. It's way down south in December, and it finally makes it back to where it started again a year later. That's what a year is. It's the time it takes the sun to do its trip around the ecliptic, the sun's path against the background of stars. Now the moon, I've already described the moon's phase thing. That's one thing about the moon. That depends on how far away from the sun in the sky it is. Like if it's near the sun in the sky, it's a crescent. If it's a quarter of the way around, you're going to have one of those first or third quarter moons. If it's on the opposite side, you're going to have a full moon, or maybe a lunar eclipse if it gets right in the Earth's shadow, which is rare. But in any case, what does the moon appear to do? Here's the thing. The moon runs around the same stomping grounds as the sun does in the sky. Generally speaking, you never find the moon very far from the ecliptic. And the ecliptic has all these zodiac constellations. In fact, you know what? This belt in the sky, if I give a little leeway either side, kind of like it's a highway, and that's the ecliptic is the center line marker. You know, the sun goes right down. Include the lanes and a little bit of the right-of-way grass on the side, and you've got the zodiac. The zodiac means a zoo. It's a bunch of constellations, mostly named after animals. And it's like, what's your sign? Pisces, you know. So what is that even supposed to mean? It's supposed to mean that the sun was in front of the stars of Pisces when I was born. Actually, things have changed, and it's off by a month, but oh well, tell the astrologers. I think they know, they just don't like to talk about it. In any case, so the moon runs around in the same general part of the sky. It doesn't stay right on the ecliptic. If it did stay on the ecliptic, we would have a solar eclipse and a lunar eclipse every month, and we don't. They just cross sometimes. The moon gets about 5 or 6 degrees, a little bit, either side of this. It runs off in the same general direction towards the east compared to the back, but it has to go to the bathroom worse. It's in a bigger hurry to get to the back of the bus, and it takes 27.3 days. The sun takes a year. The sun takes a year. I wrote a year somewhere. The sun takes 1 year. Moon takes, now it's a little bit confusing because I said 29.5 days earlier for the moon phase cycle, and I kind of hedged a little bit. The moon takes 27.3 days. The reason the phase cycle is 29.5, even though it goes around every 23.7, is because it's not being lit so much by stars. It's being lit by the sun, and the sun, well, it's a star, but you know, is moving too. So it's kind of like they're off, and the moon is winning, and the moon gets a complete lap in, but it has to catch up with the sun. Second time around, that's an extra 2 days or so. So we have the moon taking 27.3 days, generally going through the zodiac and generally taking the same general path the sun does. But all that's so slow that you still see the moon rise in the east and set in the west, kind of, sort of. But what about planets? What about Jupiter and Saturn and things like that? Well, Jupiter and Saturn are beautiful in the evenings these days. I go and walk the dog, and they're like coming up in the southeast when I first take the doggie out, depends on when the dog's out. If I go out again later with the dog, she has to go a lot. Then they're up higher and further over toward the west because they also move across the sky from east to west, but they also are heading toward the back of the bus. And so Jupiter, for example, is also moving this way and also stays in the zodiac, though not right on the ecliptic. It takes 12 years. Jupiter takes 12 years to go eastward through the zodiac. Saturn takes 30. In my life, I've seen Saturn do 2 laps around the sky. Oh, rises and sets every day. But as far as its eastward journey against the background of stars, I've seen it do 2 laps. I've seen Jupiter do 5 laps. Mars goes around a lot quicker every couple of years. Venus and Mercury, they're weird. Venus and Mercury seem to like have this affinity for the sun. They're never very far from the sun. You can see Jupiter and Saturn way clean over on the other side of the sky from the sun. Not Mercury and Venus, and you know, Mars can be too. Not Mercury and Venus though. They kind of hug the sun. They never get very far in the sky from the sun. There's one more weird thing planets will do. We're going to be talking more about this. It's rather significant. It's a weird thing called retrograde. I actually remember in 6th grade, my public school, elementary school teacher didn't like science and hardly taught any, and a friend and I complained, "You're not teaching us any science." So she said, "I'll show you some science," and she got some friend of hers to come up with a list of words for me and my friend to go look up. Busy work, keep us busy. One of those words, retrograde. Yes, I learned the word retrograde in like 6th grade. I don't know if I understood it then or not. I do now, and you will too. It's this weird temporary backwards motion that planets will do. Like, you know, like Jupiter's going east slowly, then it turns around and goes the wrong way for a little bit, then it resumes. Now, if you had physics EP last year, you might have heard this. You might know what I'm talking about. If not, you're probably going like, what? Why would a planet turn around and go backwards? That's weird. You're right, that is weird. That deserves some discussion, and we'll do that. But what I wanted to do in this short little video is show you about the moon phases. I wanted to show you that there's this general eastward motion of planets through the sky like that. And actually think about this: sun, moon, Sunday, moon day. There you go. Tuesday, pattern's broken. No, Tuesday's martes or Marty, Mars day. Wednesday, miércoles. That's in Spanish. That's Spanish. That's Mercury day. Thor's day. It's really Jupiter day. It's kind of like got changed in translation. Friday, Freya day, I think, but it's Venus day, Viernes, and Saturn day. These motions of these lights in the sky moving weirdly against the background of stars, like only those 7 days of the week, those 7 naked eye objects, Mercury, Venus, Mars, Jupiter, Saturn, Sun, Moon, they had permission to wander the heavens, though with restrictions. They weren't allowed to get out of the zodiac, and they mostly went east, but every now and then they went west. Well, some of them. What a baffling array of weirdnesses to be explained, and yet that is the obvious view, meaning you walk outside and you just plain see this stuff if you pay attention for a long time. I will call this good for now supplementation wise and back it up more in class, but you've got this to rewatch if you need to. And bye.